All right. Good morning, everyone. So this is the cyber engineering, CI infrastructure engineering brown bag for today, Friday, April 26th. Today, we are privileged to have Michael Johnson from Indiana University. He's also a contributor to the perfSONAR project. He's going to be talking about something from perfSONAR today. It's an introduction to pSConfig web admin. So, Michael, take it away. Thanks.
Hello, I'm Michael Johnson. I work at the Global NOC at Indiana University, and I mostly work on GUI projects like the toolkit redesign, as well as
outside
graphs. I'm sorry, thought I heard someone. Current project is the pSConfig web administrator. Which allows you to configure meshes in a graphical fashion. So my plan is to go through a little bit of perfSONAR background. I think most people here probably have a pretty good idea of some of it, but we'll go through it quickly and then talk about how meshes are configured and how the GUI tool can help this process. Outlines. So perfSONAR provides us with measurement tools for network performance and troubleshooting, as well as frameworks for running tests on a regular basis, and storing the results of those tests. We also have mechanisms for centrally managing testing. This is where PWA comes in. It helps that process. We have tools for visualizing and analyzing the data, which is not really part of PWA here. And we also have tools for collaborating with other perfSONAR users, including your own organization or other organizations, etc. This is another thing that PWA will help facilitate. Let me see if I can make this full screen here. Okay, let's see. So typically when you want to run a mesh of tests, you have some centrally managed configs. Used to be this would be in the MeshConfig format, and now we use pSConfig. But at the end of the day, it's just a set of configurations in a JSON file, which is typically published on a web server where all the nodes that need to can access it and pull it down, and then they'll know what tests that they need to run. So the kinds of things that go in these configs are, list of the tests to run, typically throughput, latency, loss, trace route, etc., as well as what host should be involved, schedules for the tests, and test parameters such as the tool to use for the tests, protocols, etc., and how and where archiving of test results occurs. So, and you can add nodes to a mesh by using this pSConfig directive, just adding a remote, and in this case, configuring the archive, which you usually want to do. So here's a little, just top level view of the Madash gives us a grid view of test results and allows you to see patterns with different host pairs and all that sort of thing. Similar for latency and loss. And then you get down to the more detailed test results, and you going through some of these results. And this is just a random pair of hosts on our dev test bed, but you can see that there are throughput results for TCP and UDP, and we're getting loss from TWAMP and IPERF3 UDP tests, as well as ping. And then we have one-way latency results from TWAMP and round trip time as well. So all of these tests need to be configured within the pSConfig format. So yeah, perfSONAR provides pSConfig, which allows you to configure your mesh of tests. This controls what tests the nodes will participate in, as well as where the results get archived, and the dashboard uses this information as well. So the tests are scheduled and run using pScheduler, which handles test negotiation, scheduling, running, managing the test, and archiving the data. pSConfig takes a mesh configuration in JSON format, manages the pScheduler tasks. So, if you're used to dealing with like the MeshConfig format, like the pSConfig is what replaces that, or has replaced that. Typically, this configuration is stored in a static file, and typically one file per mesh, which has some limitations. So for one thing, it's difficult for users to manually edit these configs. They're JSON files. Typos can break things, or things don't always work the way that people expect them to. You have to remember the names of all the fields and refer to the documentation to figure out how to declare whatever it is you're intending for things like test specifications. It's also really difficult to collaborate across organizations. You kind of have to have one person or organization in charge, or find a way to share the files. You could use configuration management within one organization. A number of people are using like a GitHub cron workflow whereby you store the mesh config on GitHub and give only certain people access to it, and those people can commit to it, and then you have a cron job that pulls down the latest config, daily, hourly, whatever, and builds it. And these sorts of things work, but they're kind of cumbersome. So PWA, the pSConfig web admin it's a web-based interface that allows you to define and publish pSConfig and MeshConfig meshes. And then the tests are created, and the Mad gets the topology information from there. It's a user-friendly interface for creating the pSConfig configurations. It publishes dynamic configs rather than using static config files. So this is more flexible in some ways that we'll see in a minute here. It allows multiple users to collaborate on configuration of the test specs, host groups, and configs. So if you want to work with someone at a different organization, you just give them an account on your PWA instance and give them access to the meshes that you want them to be able to manage, and now you can collaborate on those configurations without jumping through a bunch of hoops. You also have super admins who have access to additional functionality that's more like administrative, and as well as global access to everything in the PWA instance. And there's some flexibility in saying, like, this user can modify this mesh but not this other mesh, and etc. So here's how PWA fits into the perfSONAR architecture. This probably looks familiar to a lot of you. At the bottom we've got our tools that run the actual tests, pScheduler running them, pSConfig that's kind of managing pScheduler, admin where the test results get stored, and then at the top level here we have pSConfig web admin, which is generating pSConfig to control all the testing. The toolkit GUI does a similar thing, except it is limited to tests running on the one host. So PWA has a number of advantages, such as it makes it easier to modify the config, it's less error prone, you're filling out forms rather than editing raw JSON. Like I said, there's multi-user support, which facilitates collaboration. There's some access control. It also has an authentication module that supports a number of federated and single sign-on schemes, which is also extensible. So schemes that I, just off the top of my head, I know it supports. Well, there's a local auth option, GitHub, Facebook, I want to say Google, OpenID. I know I'm missing some. I think there's an LDAP module. So there are quite a few different options there. PWA also integrates with a lookup service and makes it easier to leverage the information in the lookup service to create your configs. So yeah, PWA has a few different components here. Obviously, there's the admin interface, which has a web-based UI. There's also a REST API that goes along with that, and a host cache. And what this does is it actually pulls down all the data from the global lookup service and stores it locally. That allows you to query on it quickly and easily. You can also have private lookup services, and you can have a combination of the global and private, or you can also just manually create hosts, which are referred to as ad hoc hosts. There's a publisher, and this is what publishes your actual config to a URL where your nodes and where your mad-config can get to it. And then there's the authentication module as well. So here's just a little overview of the pSConfig format. Again, this probably looks familiar to people. I just pulled out like test specs as an example of what this looks like. So, if you wanted to come in here and change, the packet count that your latency BG test is putting out, you would come in and edit this file and then, wait for the nodes that are in this mesh to pull it down, and then they would get the results. This file had a couple hundred lines probably, and that's a pretty simple config. So, it gets unruly pretty quickly in some cases. So within PWA, the same kind of changes can be made using this sort of interface. We have drop downs for the tool, and you can set the schedule type and the bucket width, packet interval, all the same parameters that you can give it through pSConfig are represented here, and with reasonable default values and a little bit of help as to what these things actually mean. So PWA takes the pSConfig format, the different sections of it, and breaks that into separate components. So first of all, hosts are just records for individual hosts. These are drawn from the lookup service or lookup services, and also your manually defined hosts. And there are some things that are configurable at the host level, like you can set a flag for a host to always archive its test results locally, no matter what, that sort of thing. We also have host groups, which allow you to define a list of hosts that are going to be participating in the tests, and then we have test specs that, the list of test type and test parameters, like the tool or protocol that's being used. What is the schedule of it look like? And then configs pull together the information from the test specs and the host groups to create your ultimate pSConfig JSON that has all that information in it. All these hosts and records, host groups, and test specs are reusable. So, if you have say all your throughput tests use the same parameters, or you have a couple different sets of throughput parameters that you always use, then you would only have to define two test specs to cover those things, and then not have to recreate them later. and then also updating one of them would update them all. All right, I already covered this. Yeah, I already covered the components for the most part. I'll just elaborate a little bit here. Yeah, the admin interface has a REST API as well. Publisher supports outputting in pSConfig or MeshConfig format, depending on what you need. It's just a URL that takes the place of the pSConfig JSON file, and those URLs are what you feed to pSConfig and mad dash to configure the tests and display your results. So I'm going to go through a live demo here. Before I jump into that, are there any questions so far?
Michael, I had one. Does pSConfig in its current form save changes over time, so I can go back and look and say, hey, what did I do 2 weeks ago, because maybe there was something I screwed up or whatever?
No, it doesn't do that at the moment. That would be an interesting feature to have.
Cool, thanks.
I'll make a note of that. So here's, any other questions before I go dive into this? Okay, so this is basically the basic login screen that you see. I have this set up just very simply. In some cases, you might have multiple different authentication schemes, in which case you might have to select, how you want to authenticate and that sort of thing. But let's see. So when you log in, you see basically a list of configs that you already have defined, and this is just a test host. So these are just, kind of random tests. The host page shows you all the hosts that are in its database, and so you can see it's like we're looking at like 1,900 hosts here. So that's basically whatever's in the global lookup service at the moment. If you had added your own like private lookup service, then you would see more and that sort of thing. And then you can search. So I might search. Help if I click there first. So if I search for this is something that I want to find, like it'll give you some results, and then you can see some of the host details down here. Host groups allow you to create a list of hosts that you want to use to test to, and it's specific to a service type. So yeah, right now you have to, it's bound to a service type. There's been some discussion like, hey, it'd be useful if we could have like a host group that you could use with multiple different service types. So that's something we might investigate in the future. But anyway, you select the kind of test you want to run, and then here's the list of hosts that's already configured there, and you can add more by typing here, so I could add one there. I'm not going to do it right now. And then test specs. This is where you control the test parameters. So like in this case, we have a latency test. It's running continuously in the background. So really it's a latency BG test. And if you change some of these parameters, the other parameters that are available change. Because if you're running, the test on an interval, then you need to specify what the interval is and the duration of the test. So it adapts to what it is based on what the choices you've already made. So rather than just go in and edit like the variables in the JSON, you can do it through this. Let's see, throughput looks pretty similar. Wait, that's not throughput. That's throughput. Like TCP and UDP. Again, some things adapt when you change it. This is the issue tracker. I'm not going to click it right now because this goes to GitHub. This goes to the documentation, which is just on the perfSONAR docs site. So there's a bunch of documentation there. And the settings thing at the bottom here, this is your account profile. So this is actually part of the authentication module as opposed to PWA itself. You can change your password, update your profile, and stuff like that there. And also create groups, which you can use for access control. Okay, let's see. So that's the kind of basic rundown of the interface. So I was thinking that we could just go ahead and create like a basic mesh here. So I'm going to add a new test spec. Let's just do a UDP throughput or something. And throughput, we're going to use iperf3 and we use UDP. So we'll set the bandwidth to like, I don't know, 50 megs. Let's do V4 and V6. And then we just hit create, and this should show up in our list of test specs. It does. And then we already have, in this case, a couple of host groups, but let's go ahead and create our own just so I can demonstrate it. So again, throughput, and then let's do picking a couple hosts that I'm aware of. It also has a dynamic option, which I'm not going to demo right now, but that allows you to do things like use a little script to filter like which host you're interested in having the group. And let's see. Okay, so I probably don't need to do anything on the host section now because all those hosts already exist. And we'll just make a new config. We'll just call it UDP mesh or something. And one thing you'll notice here, you can specify like central MA URLs. So I might put in like, I don't know. It's Esmond. You can have multiple central MAs. There's an option to force it to archive on the endpoint of each node. We're not going to do that right now. So now that I've hit create there, I can open the my new config in either pSConfig or MeshConfig format. I think that works. I've got something covered. Okay. There we go. So let's see. Okay, this is missing. Hold on, let me go back. Let's see it. Oh, I didn't add the test. There we go. So yes, you can add any number of tests to one config. And I forgot to do that, and that's why nothing is showing up. Host group, use our new host group that we just created. And test spec as well. And we'll add that. Oops. Okay. And then we'll hit update here. And then hopefully we'll have better luck with this. Yeah, there we go. So here's this, standard pSConfig output. We've got lists of archives. So it's got a config. The config archive represents the central archive that's being used for the whole config, and then some of these hosts have like additional archives that have been defined at the host level as well. And then these, addresses, it's just basically giving us our list of hosts. The groups showing the list of which hosts are in them, and then you can see the test parameters that we've selected here, as well as the schedule that this is going to run on. And then the task pulls together the schedule, the test spec, and the group. And then these hosts here have like some extra archives configured, so that those are showing up there. You can also view this in MeshConfig format, and this is essentially deprecated at this point, so it's not necessarily recommended, but it is there. It is an option. If you want to point other hosts at it, you can. Okay, so another thing that's worth pointing out here is this auto config format. So if you just enter a host name here, it gives you a separate URL. Let's see if I can get out of full screen here. But there's a separate URL for each host. And what this does is it gives you a list of all the tests that host needs to participate in. So what you could do would be you could have each host set to use its own like auto config URL, and then it would pull down all the test information it needed. And in that way, if you say you added another test and put the host in it, you wouldn't have to like pSConfig add another URL. It would just be part of the URL that it's already using. So, let me get out of full screen. And that gives you a sense of the URL that you're looking at there. So yeah, you can do that with any host that's in the mesh, in any of the meshes. A couple other things worth mentioning. I sort of touched on this, but measurement archives can be configured at a couple different levels. One being the config wide level. So this is like for your whole mesh. You'll be using this archive. Again, here you can force archiving on each endpoint individually. You can also specify whether individual nodes should use their own local MA, as well as a way to override the local MA URL. It defaults to just generating it, but you can override it. Then there are additional MA URLs as well. So, you can do some pretty sophisticated things in terms of where you archive your data. There's no place for it at the host group level, but I think it's not in the test spec either. But let's see. Any other questions at this point? Okay, so that was the main part of the demo that I wanted to do. Let's have a few other things to mention. Yeah, so you can have multiple users defined, and each config, host group, and test spec has their own set of admins defined, so that there's some flexibility in terms of, oh, I want to give this person access to change the host group, but not the test spec, for instance. So, say you wanted to let people like add hosts to the mesh, but not change the test parameters themselves, like you could do that. Super admin accounts can control everything. A lot of the host details are only editable by super admins as well. There are some limitations here. Currently, the user management is mostly handled from the CLI. So, like, if you need to create new users, that sort of thing, you need to do that from the CLI. But there's another option that is to allow people to register through the web UI. So there are a couple different ways to get the users created. But there's no graphical user management as part of the auth module right now. So there's some optional features that could be useful for people. One is private LS integration. So basically, one of the daemons that this runs is an LS cache, which by default caches all the data in the global lookup service, and then allows you to query based on that. You can additionally have use private lookup services, and so you can have multiple data sources. So in that case, they all get like brought into your local cache, and you can use them as one set of host data. You can also filter subsets of like the global lookup service. So if you only wanted to see hosts from like a certain community, you could do that, or something like that. The authentication module supports like some federated auth through various means, which I described earlier. By default, out of the box, it's just using local auth, but you can enable GitHub auth and Facebook and a bunch of other things. I think notably, it doesn't support shibboleth right now, but that's something that could be added. It's extensible, and it uses a module that I think already supports shibboleth, so you could add that as well. The publisher has a few like different things you can do with it. Typically, running one publisher is enough, but you can run multiple instances of it. You can like either on the local host, or you can spin up an additional host or hosts and have them run publish on them as well. Or those could be geographically distributed if you want. A lot of different possibilities there, but yeah, it's possible to run the publishers standalone. And then host auto config I already explained. And then there's a REST API for both the administrative interface as well as the authentication module. So there's a lot of like automation that could be done using those. I think I already covered this. Yeah. So the status of PWA right now is it's still in beta. but the production version is going to be released in the next perfSONAR feature release, which will be 4.2.0. 4.2.0 beta 1 is going to be coming in a couple months probably. Currently, the deployment model of this is Docker-based, actively in the process of getting RPM packaging working, and I mean that's partially working right now, but it still needs a bit of work. And the Xeon perfSONAR people are going to be creating Debian packages as well. So deployment on this will be a lot easier by the time this is released. Also, more beta testers are certainly welcome. I know of a few people running this in the field, like some in production. But yeah, if anyone is interested in this, I would highly recommend just checking it out, and I'll get back to this, and putting it through its paces and see if you see problems or things that can be improved, and that sort of thing. So I have this illustrating the Docker deployment model. Obviously, once it's packaged, this will be a little bit different, but the overall architecture is the same. So first of all, this is using Nginx. It's really just using the web server as a remote proxy. So I already have Apache configs that will allow you to do the same thing with Apache. So which is a more familiar web server for a lot of us in perfSONAR land. And then there's the admin application, the main application that has a static JavaScript front end and a Node.js backend, and then the publisher or publishers, those just run as daemons and also proxy through Nginx. And then MongoDB is a data store for most of this stuff. There's the authentication module. This is maintained by another group here at IU, but we kind of have our own fork of it right now. So I'm kind of tracking what they're doing. We'll see if it makes sense to keep tracking them or if we kind of go our own direction. But it has a lot of extensibility though, in terms of adding different authentication methods and that sort of thing. And then we're using a mail server just basically for password resets or account validation if you're allowing people to register. And then a lot of this stuff is really specific to Docker, so I'm not necessarily going to go into that. The tech stack this is running on is Node.js. It's an Angular, and the theme is Bootstrap based. MongoDB for the backend for the main data store, and SQLite for auth. Again, Nginx, which we'll be using Apache soon. You can use whichever one you like. And the RPM and Debian packages are coming soon. You'll notice this is a bit of a different tech stack from a lot of the other perfSONAR components, and so it may be a little bit of a struggle or a challenge to support it, just because a lot of these are kind of like outside of our main areas of expertise. But I think that'll be fine. So some resources if you want to dig further. There's documentation on the perfSONAR doc site, and if you look at the GitHub project, you can see a lot of information there. I mentioned the pSConfig docs because those might be useful in understanding what some of the parameters you're setting through PWA actually mean. I should have put a link to Docker Hub here too. We have a Docker Hub account, but it's linked from the GitHub. So, but I'll add that before we send out the slides later. That's the end of what I have. Are there any other questions, comments, or anything?
Let's see. So we have one question in chat here. It says, would you mind if you run the pSConfig file you have created using a pScheduler agent?
So let me make sure I understand the question. The question is, can you run your pSConfig output using pScheduler? Is that the question?
That's my understanding of the question. Yeah. So I think the question is, can you use pSConfig to generate a config and then use that config in other parts of the system?
I mean, that's more or less how it works. Really what happens is that pSConfig, the pSConfig daemon, consumes the pSConfig output from this, and it creates tasks in pScheduler to match what's been requested of it. So really it's pSConfig that uses this directly.
Right, and then it drives the other components directly based on the directives in the config file generated.
Correct, yeah.
Okay. Next question, is there any integration between pSConfig and the Ansible modules from last week's talk?
No, well, the extent of the integration that I'm aware of is that I believe the Ansible modules can be used to deploy PWA. I don't know how far that integration goes. Is there a specific thing that you're wanting to know about?
So Kate, if you want to, you can either unmute and ask, or just type it in the chat if you want to follow up. Either way is fine.
I was just interested if there was some discussion kind of going on during the presentation about like managing configs somewhere else so that multiple people can update them, and then maybe pulling those into the pSConfig or PWA. And then I was wondering if any of that was you could do any of that with Ansible or after the fact, you know, pushing the PD. I guess you don't really need Ansible to push it from PWA, do you?
Sure. So I'm not super familiar with the Ansible modules, but I have talked to the Ansible guys a bunch about a bunch of the PWA stuff. And, I know that part of what they're doing involves deploying things with PWA. I imagine that might look like adding the pSConfig remote to each node to point at your PWA host auto config, possibly, or just at the relevant, mesh configs that it's going to use. You could also automate setting the pSConfig data source for Madash in a similar way, I imagine. So that, if you had your config set up, you knew what the URL was going to be, you could basically use Ansible to push that out to Madash and push it out to the individual nodes and anywhere else where you might need it.
Thank you.
Sure.
Excellent. Other questions? Either type them in the chat or feel free to just speak up. Going once. Going twice. Okay. Well, thank you again, Michael. This is really great. And this looks like a really sweet tool, actually. So again, I guess this is going to be available in beta in just a couple months, yeah?
Yeah, I mean, and if you're feeling adventurous, it's really, you can try it now. It's on Docker Hub. It's on our GitHub page. You can talk to me directly if you want to if you need help getting running. There are documents on it. So yeah, you can start playing with it now if you want, or to wait for the official beta as well.
Okay, that's fantastic. Thanks very much. And
thank you.
So I guess you're going to send me the slides. You said you had another item or two you wanted to stick in one of the slides, but feel free to send me those later and I'll get them posted.
Okay.
And yes, thanks very much, everybody, for attending today. And thanks again, Michael, for a great talk.
You're welcome. Thank you.
All right. Cheers. Have a good weekend, everybody.
Bye.